found in the middle or the centre of the atom have a charge of +1. They're positive, positively charged protons. Neutrons, the other particle found in the nucleus, have no charge. They are neutral. Neutrons are neutral. They have no charge. And then finally, electrons are negative. They're negatively charged. So they've got a charge of -1. Electrons are negatively charged, a charge of -1. The next thing that you need to be able to do is calculate the number of protons, neutrons and electrons in different types of atoms. So the example that I've got on the screen here is nitrogen. And you'll be given these symbols on the periodic table on your chemistry data sheet. You'll notice that there are two numbers. The biggest number is what we call the mass number. And the smallest number is what we call the atomic number. Now you need to know some key rules to be able to calculate the number of protons, electrons and neutrons. To work out the number of protons, you need to use the atomic number, because the atomic number is also called the proton number. So whatever the atomic number is, that's the number of protons that you've got in your atom. So the number of protons in this case is 7. For the electrons, it's the same. So the electrons in this atom, we look at the atomic number, which is 7. So in this atom, we've got 7 protons and 7 electrons. Finally, to calculate the number of neutrons, you need to do some subtraction. You need to get the mass number and the atomic number, and you need to take the atomic number from the mass number. So in this case, 14 take away 7 gives you 7. And the reason we can do that is because of this little fact here. The sum of the protons and neutrons in an atom is its mass number. So up here, you've got your protons and your neutrons. And if you take away your protons, you're just going to be left with your neutrons. So that's what we're doing down here. So just to recap, to find out your number of protons, you look at the smallest number, which is the atomic number. To find out the number of electrons, you do the same. You look at the smallest number, which is the atomic number. And to work out the number of neutrons, you get the mass number, which is the biggest number, and you take the smallest number, or the atomic number, away from it. Now in this case, it's got 7 protons, 7 electrons, and 7 neutrons. They're not always the same. So you must, when you're calculating your number of neutrons, do the sum, get your mass number, and take away the atomic number. The reason that atoms have no overall electrical charge is because of the little facts that we talked about on the previous slide. Protons are positively charged, and electrons are negatively charged. All atoms have the same number of protons and electrons. So if you've got 7 positive protons and 7 negative electrons, overall you're going to have no charge. and that's the same for all atoms. So the next thing that we need to do then is try and draw these electronic structures. And you could be asked in an exam to either complete the energy shells or calculate the number of electrons, but you must know the rules of electronic structure. So we've got our nitrogen here again, and we've got the number of protons, which we've calculated, the number of electrons, and the number of neutrons. In the centre here, we've got our nucleus, and we know that in the nucleus, you've got your protons and your neutrons. So what I've done there is put the 7 protons in, the 7 blue ones, and the 7 neutrons. What we then need to do is draw on our electrons, and we know that they go in shells around the nucleus. In this case, we've got 7 electrons. Now you need to know the rules for filling up these shells. Your first shell can only take up to 2 electrons, so it can't take any more than 2 electrons. So in this case, I've put 2 electrons in the first shell. But overall, I've got 7. So I still need to add another 5 electrons. So that's what I've done in the next shell. 1, 2, 3, 4, 5. Always count up to check that you've got the right amount of electrons. 7 there. 1, 2, 3, 4, 5, 6, 7. Now the rule for the second energy shell is a bit different, because they can take up to 8 electrons. Now in this case we didn't need to use any more, because we've only got 7 electrons in total. But if it was a bigger atom, we would still put the 2 electrons on the first shell. Then we would fill the second shell with up to 8 electrons, and then we could draw up a third shell. So the first shell is a maximum of 2 electrons, and the second and third shells can fit up to 8 electrons. Just while we're looking at the electronic structure and linking it back to the periodic table when we talked about how those different elements were arranged by their properties, well, the number of electrons in the outer shell determines which group it goes into. So in this case, I've got 1, 2, 3, 4, 5 electrons, and because I've got 5 electrons in the outer shell, it goes into group 5 of the periodic table. What I want you to do now is pause the video and practice. So there's 2 questions here. The first one is to draw the electronic structure of sodium. The second one is still on the same topic, but it asks the question a little bit differently. So you'll need to think hard about that one. So you can pause the video and spend some time trying to work out those answers. So let's just have a look at the first example of sodium then. Hopefully we've remembered that the smallest number, or the atomic number, tells us the number of protons, and it tells us the number of electrons. To work out the number of neutrons, we do the top number and we take away the bottom number. Okay, so in this electronic structure we've got an atom with 11 protons, 11 electrons and 12 neutrons. So if we draw our nucleus in the middle, we won't look at the neutrons and protons this time. We'll just look at the electronic structure. And so we've got 11 electrons So we need to draw one shell first, and we put 2 electrons in there, because only 2 can go in the first shell. Then we draw a second shell, and we can put up to 8, and we need to use all of these this time. So in total there at the moment we've got 10, but we need 11. So we put one more shell on, and we put the last electron in. So our electronic structure written in numbers is 2, 8, 1. Because it's 2 in the first shell, 8 in the second, and 1 in the last. And if we remember that rule about electrons in the outer shell, hopefully we should know now that because this has got 1 electron in the outer shell, sodium is in group 1 of the periodic table. Here is the structure for neon. It's got an atomic number of 10, so we know it's got 10 electrons. So we put 2 in the first shell, and we put 8 in the second shell. And what you can see if you compare these two atoms is, this one, 1 electron in the outer shell, so it's in group 1. Neon has got a full outer shell, so it's in group 0 because the outer shell is full, or sometimes it's called group 8. So just to expand on that a little bit more then, I've got 2 different atoms here. I've got lithium and helium. And we were saying that depending on the numbers of electrons in the outer shell, that results in the group of the periodic table that element's found in.